we're back with another math challenge. This is the senior math challenge from November 2016. This is aimed at school pupils in the UK who are 16 to 18 years old. I was actually teaching when this was out, so I might have seen these questions before, but it's been 5 years, so I won't remember the answers, but I might remember some of the methods. So we'll see if I start to recognise some of the nicer, harder questions at the end, what we do. But the way it works, there's 25 multiple choice questions. So if you haven't done one of these before, you've got a few options. There's 25 multiple choice questions. You may pause the video now. In the link below the video, there is a link to this actual paper, so you can have a go at it now. I will warn you now, it is tricky. It is, even though it's aimed at 16 to 18-year-old pupils, the majority of 16 to 18-year-old pupils who study maths will find this very difficult. So it is a difficult paper. Don't expect to finish it in the time limit. We've got 90 minutes, so I'm going to try and stick to close to 90 minutes, but because I'm talking through at the time, it might take me a bit longer. And the type of maths you see will be different. This is a different sort of thinking required. They're not like, there are a lot more abstract-y problems for hardcore maths lovers, which I love them. And the way it works is there are two sort of sections. The first 15, apologies, getting the wrong one. The scoring rules for this is different to the ones that you do lower down. The scoring rules for this is as follows. If you get, you start the test with 25 marks. So at the very start of the test we get 25 marks. And if we leave one blank, nothing happens. If we get one right, we get 4 marks if we get it right, and we lose a mark for every one we get wrong. So if we guess and we get it wrong, we lose a mark. So our lowest score is 0. If we guess every question we get them all wrong, we'll score 0. So the way to approach it, that I would do it, is one, I would work out what I think the answer is and then see if my answer is in one of the 5 options. That would be my number 1 tip to you. My number 2 tip to you, if you're going to guess, you need to make sure that you've narrowed it definitely to 2 options. And at that point, it's actually your expected value for guessing is actually better than not guessing. So if you're absolutely sure it's between one of 2 options, you can have a guess, but I would suggest you don't guess if you work out an answer and it's not there and you don't know where you've gone wrong. They're very good at putting wrong sounding answers that look right up there. So we're going to have a go. You feel free, I'm doing this live on Twitch as normal, so you feel free, if you are watching on Twitch, to point out any errors I make. You can have a go at what you think the answer is, but please don't tell me the answer until I've had at least a go at the question. So obviously you don't want to shade my opinions there. So we're going to crack on. The time now is roughly just after 6:10, so we have got till about 20 to 8 to have a go at all these, but again I might take a bit more than 90 minutes because I will be chatting as we're going. So question 1, how many times does the digit 9 appear in the answer to that calculation there? It's either going to appear like once or 9 times. It's definitely going to appear once because you're doing 9 times 1 at the end. I think if you multiply this by 9 you get reverse, don't you? You get a 9, and then 9 2s are 18, carry 1, 9 3s are 27, carry 1, and so on. I think you get something like this. I think that's the answer you get when you do it. You 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, carry the 1 from 18 gets you this 8 here, and so on. So I think you continually carry enough on each time that you're adding on. 9 times 3 is 36, plus the 2 from the 27 gets you this 8 here. So I think you're going to get 8s forever. And finally, this 9 times this 9 gets you 81, which gets you the first 8 digits here. So I think you're just going to get it once. It was either going to be once or 9, and it depends on what the sort of repeating pattern was. On a Monday, all prices in Isla's shop are 10% more than normal. And on Friday, all prices in Isla's shop are 10% less than normal. James bought a book on Monday for £5.50. What would the price of another copy of this book be on Friday? So if he bought this on Monday and this was 10% more, the original was £5. 10% more than £5 is £5.50. If the original is £5, then 10% off on Friday would be 10% less, which would be £4.50. Right. The diagram shows a circle with radius 1 that rolls without slipping around the inside of a square with side length 5. The circle rolls once around the square, returning to its starting point. What distance does the centre of the circle travel? So the centre of the circle is here, and the centre of the circle is 1 from each of the faces. So the centre of the circle will go in a square, and the length of the square, because you're going to lose 1 from each edge, you're going to lose 1 from here, and then when the circle's at this side, you're going to lose 1 from the other side as well. The length of each side of the inner square is 3. So it's just going to be 12. It would be slightly more fun to work out how far a point on the outer circle would travel, because it will be rotating as you're going, and then you get some very weird shape there. But yeah, imagine the point in the outer circle will just travel 12 as well. It wouldn't travel 12 because it would travel in an arc, wouldn't it? Right. Alex draws a scaling triangle. One of the angles is 80 degrees. Which of the following could be the difference between the two other angles in Alex's triangle? Could be the difference between two of the angles in Alex's triangle. Well, it can't be 0, because if the difference is 0, it would be isosceles. It can't be 100 or 120, because if you've got one angle of 80, the other two have to add up to 100 together. There's no way you can get a difference of 100 or 120. So it's going to be one of the other two. And my guess is one of the other two will also produce an isosceles triangle. So if we had the other isosceles triangle, it would be 80, 80, and 20. That would get you a difference of 60. So 60 is not possible. Although it is possible to make a triangle, it wouldn't be scaling. So I believe it's 80. And the way to get an 80 is you could have 80, 90, and 10. Oh, that would be a right angle triangle, wouldn't it? Ooh. Ooh, ooh, ooh. I'm missing something here. So if you had a difference of 80, you'd get 80, 90, and 10, wouldn't you? So that doesn't work. So what am I missing? So if you have one angle of 80, the other two angles have to add up to 100 degrees. For them to have a difference of 0, they would have to both be the same. So you could have two 50s. For them to have a difference of 60, it would have to be 80 and 20. For them to have a difference of 80, it would have to be 90 and 10. For them to have a difference of 100 is not possible, because then you'd have an angle of 0. And they can't have a difference of 120 by a similar reason. So it's one of these three, but aren't all of these... This one's isosceles because it's got two 50s. This one's isosceles because it's got two 80s. And this one is a right angle because it's got a 90. So my guess is that the definition of a scaling triangle to these guys is a triangle with three unequal angles and sides. And it might be able to include a 90-degree angle. And that might be my poor definition of scaling. That would be my guess, is that the only one that makes sense, A and B are both isosceles, so it can't be either of them, and D and E are impossible. So my guess is it's C, on the basis that they're definition of a scalene could be a right-angled scalene triangle, and I believe that's true. You can have a right-angled triangle that's scalene, and you can have a right-angled triangle that's isosceles. So I think that's my faulty definition in my head of what a scalene triangle would be. See, I wouldn't call a right-angled triangle a scalene triangle, but I guess by definition it is, because it just has 3 unequal angles and 3 unequal sides. Right. All the digits 2, 3, 4, 5 and 6 are placed on the grid, 1 in each cell, to form 2 3-digit numbers that are squares. Which digit is placed in the centre of the grid? So we're looking for square numbers made up of these digits. So 256 is a square number. So that would be 1. 12 squared, 13 squared, 14 squared, 15 squared, 225, 16 squared, 256, 17 squared, 289, 18 squared, 324. It's 18 squared. 19 squared is 361. 20 squared is 400. 21 squared is 441. 22 squared is 484. 23 squared is something ending in 9. 24 squared is 576. 25 squared is 625, is it? So it's going to be 324 and 625. I didn't work them all out, but I knew 23 squared ends in a 9, so it won't be possible. So it looks like the only way to do it is to have 324, which is 18 squared, and 625, which is 25 squared. Then you get the same central digit. There we go. The diagram shows a square ABCD and a right-angled triangle ABE. The length of BC is 3, so BC is 3. That's the side length of the square. The length of BE is 4. What is the area of the shaded region? That's 3. The side length of the other one will be 5, the triangle, which I'm not sure it matters. So how high up is this point here? Can we say, because the height and the width are 3 and 4, that would hit 3/4 of the way down DC? That would be my assumption, because the ratios of the sides AB and BE are 3 to 4, so this would hit. Yeah, so that would be halfway. To the point where this is 2 would be halfway down this edge, wouldn't it? So the point where it's 3 would be 3/4 of the way down this edge. So this length here, D to this point here, or C to the point here, would be 3/4. And so what we've got is the area of the shaded section is going to be the rectangle we'll call big X, and the triangle is going to be big Y. Big X is the same as 3/4 times 3, which is 9/4. And big Y is going to be the same as half base times height. The height's going to be 2 1/4. Base is going to be 3 times a half. 3 times 2 1/4 is 6 3/4. A half of 6 3/4 is 3 3/8. So this is going to be 9/4 is 18/8. 3 3/8 is going to be 27/8. And in total, that is going to be, if we add those two sides together, it's going to be 18, 30, 45, 8, which is the same as 5 and 5/8. There might be an elegant way of doing that, but I believe that to be true. Which of these has the smallest value? 2016 to the power -1 is 1 over 2016. 2016 to the negative half is 1 over the square root of 2016, which is no, other way around, which is smaller than that. This is just 1, and 1 is larger than both of those. How long will you be on for my break is coming up? I've got 90 minutes to do the whole thing. My guess is I'm going to be on for at least another hour. At least another hour. I'm doing the easier ones first. The ones at the end will take me more time. My expectation will be, it's currently 6:25. My expectation, I'm going to take till 7:40 would be my expectation if I took the whole length of time for the test. That's going to be the square root of 2016. And that's going to be, I think they're already in order. The smallest one is this first one here. They're all positive, but this is this is the smallest fraction, and then the 3 on the right hand side aren't fractions, or at least they're 1 or larger. Alright. Points are drawn on the sides of a square. That's grade 8 work. I don't know what grade 8 is in your country. How old would the kids be for grade 8? Points are drawn on the sides of the square, dividing each side into n equal parts. The example shown is n is 4. Points are drawn in a manner indicated to form several small squares, 24 in the example shown shaded in some triangles. How many squares are formed when n is 7? I think we're just going to work out a sequencey thing here. This is going to be a sequence. So when n is 1, so hang on. So 1, 2, 3. So when n is 2, you get 1 square. So n squares. I wonder if there's some sort of pattern. So when n is 1, you get no squares. When n is 2, you get 1 square. When n is 3, you get boop, boop. So we got that. That's bad. And then so we get 5. 3 we get 5. When n is 4, we get 24. Alright, well, we're going to draw n is 5. This is going to be a lot of squares, I'm afraid. I might need one more to find out the nth term rule for this. It's going to be it's going to be D or E. My guess is it's going to be, my guess, if I was to make a guess now, would be D. So n is 5, which means we're going to have 4 dots. 1, 2, 3, 4. So we've got something that looks like this. Is that the one up there? Apologies, n is, so that's 24. They also draw the diagonals. They do, thank you very much. They do. That might make it easier, thank you. Yeah, almost certainly makes it easier, because I might be able to do it from the numbers I've got now. So Yeah, this looks much easier. So we've got 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's rub these out. I appreciate that, Hammer Sickle Bridge. How you doing? I've not seen you since the last math challenge. So when n is 1, we get no squares. I'm not sure that's right. If there's no partitions, there's no squares, is it? Even if you draw diagonals in, there's no squares. So when n is 2, we split into 2 bits, there's 4 squares. When n is 3, we get 4, 8, 9, 10, and 12. Good. So 4, 12, 24. The first difference is 4, 8, 12. Second difference is 4 and 4. So it's going to be 2n squared. And 2n squared gets us, I haven't done this for a long time, I'm probably setting this out in a really bad way. 2n squared gets us 1, 2, 2 lots 8, 9, 18, 18 for 32. So we need to subtract 2, subtract 4, subtract 6, subtract 8. So 2n squared minus 2n, I believe, is the nth term rule. So there might be an easy way of doing this, but when n is 7, 2n squared minus 2n equals 2 times 49 minus 2 times 7. It's going to be 98 minus 14. It's going to be 84. It has got, my guess was wrong. My guess was a long way off. There we go. There we go. A square has vertices at 0, 0, 1, 0, 1, 1, and 0, 0. Graphing, the following equations are drawn on the same set of axes as the square. How many of the graphs pass through exactly 2 of the vertices of the square? So we could draw the graph. We could. There's a couple of ways of doing this. The other possibility is we just substitute those points in. So we could say, if we call them A, B, C, D, and E, and then we try each of these points at A, B, C, D, and E. Should we do that? So the point 0, 0 doesn't hit at A, doesn't hit at B, doesn't hit at C, does hit at D, and doesn't hit at E. So 0, 0 doesn't hit at 2 points. Apologies. That's not the way we do it, is it? The category is math, and because I can't put maths as a category, I believe I've put the category as maths, haven't I? Are you just winding my leg? Yeah, I can't put maths as a category. I can do math or math problems. I don't know. I don't know what your level of ability is. So with 0.10, does that hit at any of these points? So 1, 0 hits at A, doesn't hit at B, hits at C, doesn't hit at D, and hits at E. Oh dear, there's probably an easy way of doing this. The 0.11 hits at, doesn't hit at A. I already know A's not going to work. A's only going to hit, oh no, A is going to work, isn't it? Is A going to work? Yes, A's going to work. Yes, A is going to work. The 0.11 doesn't hit at A, doesn't hit at B, doesn't hit at C, does hit at D, and D is going to work. A and D are going to work, I can just see it already. And E 1, 0. That doesn't work because that does. And then the point 0, 1, which graph does these hit? So 0, 1 hits at A, hits B, hits at C, doesn't hit D. And if X is 0, this has no solutions, doesn't hit E. So what we're looking for is letters that appear exactly twice. So what letters appear twice? D appears twice, A appears twice, and C appears twice. We think it's 3 graphs that hit exactly 2 points of the square. You could sketch the graphs and sketch the square. I just think, because I'm doing with an electronic pen, I don't think I'm going to be accurate at all. I can't use any straight line tools or anything, so I could do that. I know for certain, just by thinking about this one, that this is going to hit and this is going to hit. So I know these two, and you just have to find one of the other ones, or that particular case. And I know for certain, just by thinking of it, if I sketched it, this one wouldn't. And then you just have to check D and C and E, I think. Right. So the digits from 1 to 9 are to be written in the 9 cells of the 3x3 grid shown, 1 digit in each cell. The product of the first 3 digits in the first row is 12, and so on. So these are the products of different things. How sure are we about A is in this graph here. So the square looks like that. And this graph A, is a circle, centre at 0, 0, with a radius of 1. So the first graph looks like that. Yeah, I just know that that's the equation of a circle with radius 1. That's centre 0, 0. So it has to go through the two opposite, the two 1, 0 and 0, 1 points. No, fine. Please feel free to ask. If you ask a good question and I can give a good answer, it might help people watching. I'm recording this for YouTube, but I'm also doing it live, so it's kind of a hybrid of. You had the centre in the wrong spot, yeah. The centre of the circle is determined by what numbers go with x and y. So if it was like x minus 2 squared plus y plus 1 squared equals 1, that circle would have a centre of 2, negative 1, and it had a radius of 1. And so when there's no numbers with x and y being squared, you're just going to have a centre 0, 0. The digits from 1 to 9 are to be written in the 9 cells of the 3x3. I've just read this one, so we know what we're doing. Basically, the product of this first row is 12. And the only way to get 12, you can do 1 times 3 times 4, 1 times 2 times 6. And there has to be a 1 in the first row. So to some order, to get 12, we need to have 1, 2, and 6, or 1, 3, and 4. So we know that the 1 has to go here because we've got 2 12s. To get if the digits are 1 to 9 here, this has to be a 5. I'm going to have to use a stronger pen there, so I'll use a red pen because of being stupid. I'm going to use a red pen because you can't see the blue pen very easy. This has to be 5 because you know that 5 isn't a factor of 12, 112, 12, or 216. So the only place you can put a 5 is here. The only one of these 4 around the edge that's a multiple of 9 is 216, so 9 has to go here. And then what we have to do is put 7 and 8 in this row here. Seven and 8, so 216, does that divide by 8? 108, 54, yeah, that divides by 8, so 8 must go here. Oh, they both divide by 8. They've got to both divide by 8. Does 216 divide by 7? It doesn't. So yeah, so 8 has to go here, which leaves 7 here. And then 216. 9 eighths is 72. And you need 3 72s to make 216, which means from our 12 factor earlier, there has to be 6. From our other 12 factor earlier, these have to be 3 and 4. And 8 7s are 56, so that has to be 2 because 2 56 is a 112. and that has to be 3. So the question is, what is the product of the digits in the shaded cells? Well, weirdly, because I knew 1 was a 5 straight away, I already knew it wasn't those two. But 3 times 2 times 5, 3 times 2 is 6, times 5 is 30. It's going to be 30. Yeah. There's a couple of keys there. You can get the 5, 1 and 9 very quickly. You can get the 5, 1 and 9 straight away, and that's what you've got to do quickly, I believe. Oh, I've missed something out. 4, thank you. 4 and 3. 4 and 6, there we go. I got the 6 and the 4 the wrong way around. You mean silly, but it doesn't change the diagonal. Yeah, I did flip the 3 and 6. You're absolutely right. You're absolutely right. So it's a good thing to check with me. That's the sort of thing that if you're in the test at the end, you'd go back and just check everything works in your table. That's the sort of thing you can have a quick check at. But I was so confident that I got it right. Oops. The grid below, each of the blank squares and the square marked X are to be filled by the mean of the two numbers and its adjacent squares. Which number should go in the square marked X? Okay. Huh. Oh dear. So it's probably a nice way of doing it. What you could do is you could put an A in here and a B in here, and then you could work out X in terms of A and B, and then you could work out this space in terms of A and B, and work them all out. But I might just start guessing here. Let's see if we can do it. So if my guess is that X is an odd number, because then you can work out. So let's try 17. And if X is 17, that would be 21. If that's 21, and 17, they're 4 apart, that would be 13, and then this would be, this wouldn't work. So 17 doesn't work. I think we need a higher number. I think we need a higher number than 17, but I still think we need an odd number. So let's try 19. So 19 and 25 means that this will be 22, and then is it just going to be 3 apart? Everyone's going to be 3 apart. So this is going to be 16, this is going to be 13. That works, isn't it? Yeah, I should have probably guessed that first, to be honest. Because the way means work, it wouldn't start jumping in bigger increments because of the way means work. Whatever the difference between 10 and this has to be the same as the difference between that and that to make it the mean. And then exactly the same thing holds true for 16 and the X, and then for X and that. They all have to be the same distance apart either way, so it has to be a flat scale. So they're just going up in 3s. Should have got that quicker, I think. What is the smallest square that has 2016 as a factor? Okay, so 2016 is 1008 times 2 is 504 times 2 is 257 times 2. 257, is that a... It's not divisible by 3 or 5 or 7 or 9 or 11. Have I done something wrong? Yeah, 2016. Divided by 8. Okay, now I've not done anything wrong so far. 257. Is it divisible by 13? It is 19 13s, is it? 2013s would be 2. No, it's not 1913s. It doesn't go into 13, does it? So is it divisible by 17? Oh, I don't know. It's 257 prime. So let's check. So it doesn't do 3, doesn't do 5, doesn't do 7, doesn't do 9, obviously, doesn't do 11, doesn't do 13, doesn't do 15, doesn't do 17. Does it do 17? I think it doesn't do 17 either. 17 squared is 289, so take 17 off that, you get 261, 262. Yeah, it's not. I think that's a prime number. I think. And for 2016 to have a factor, to be a factor of one of these other numbers, they need to share same factors. So what you'd need for 2016 to be a factor of one of these, you would need 2 and 2 and 2 and 257 to go into these numbers. So 257 doesn't go to any of these, so my guess is it's E, unless I've done something wrong. I feel I've done something wrong here. But you get to the point where that's prime. I'm pretty sure that's prime, and I'm pretty sure we've done nothing wrong. Have we done anything wrong? I think I would come back and check this one if I was doing this for real, because I don't like that answer. But clearly 2016 squared has 2016 as a factor, but 2016... I know they've picked 2016 because they always do this. They always have a couple of questions in their paper that use the number 2016 because that's the year that this paper was taken. You don't think I've done anything wrong? Well, thank you, Zasuai. I don't know how to say your name, I'm afraid. I've got close. Zasuai? Josue, is it? Five square tiles are put together side by side. A quarter circle is drawn in each tile to make a continuous curve as shown. Each of the small squares has side length 1. What's the total length of the curve? So that's 1, that's 1, that would be 2, that would be 3, and then this bottom one would be 5. So we've got a 1, a 1, a 2, a 3, and a 5, the radiuses. So it's going to be the areas of the curve, the length of the curve is going to be pi times diameter. So it's going to be pi times the diameter, and the diameter is going to be 2 plus 2 plus 4 plus 6 plus 10. But that would get you all the circles, and we just want a quarter of each of them. So it's going to be over 4. It's going to be 24 pi over 4. So we think it's going to be 6 pi, which is our first option here. Okay, that felt a bit easier. Which of the following values of the positive integer n is a counterexample to the statement, if n is not prime, then n minus 2 is not prime? So to be a counterexample, what we want is for n to be prime. Apologies, we want n to be not prime and n minus 2 to be prime. So this isn't prime, this isn't prime, this isn't prime, this isn't prime, so it's not 11. And then what we want is for what this one of these values minus 2, so 4, 25, 31, 49. So it's going to be D, we think, because we want something that is not prime. but that the n minus 2 is prime for it to be a counterexample. It has to match the first statement and contradict the second one. Well, I'm happy you've joined me, Rasen. I'm happy you've joined me. I do these for a bit of fun, but also I have a YouTube channel that these go up on, so you can watch older ones, and in the links to the YouTube channel are links to the actual papers. This is not the hardest one the UK does, but it's the hardest one that the UK does en masse. So basically there are 3 tiers of papers that the UK does. They're called the maths challenges, UK maths challenges, and they've got junior, intermediate and senior. This is a senior one, so this will be 16 to 18-year-olds, but it's going to be the best 16 to 18-year-olds in the country, the ones that are doing like A-level further maths and things like that. Yeah. And then if you do well at this paper, you qualify for the next stage. And the next stage, I tell you what, is tough. The next stage is pretty tough. I had to try and help kids train for the... I once had to help kids train for the stage that were 2 up from this. And I couldn't do it. I was basically as good as the kids were because it was just so much harder than what I was normally used to. If you've got any of the American maths competitions available, I'm happy for you to send them me, and I'll have a look at them. And if they're good enough, I'll do them if they're suitable enough for what I want to do on my channel, I will happily do some. All right, what's the value of P plus Q plus R? My guess is it's going to be basically you've got if you ignore the rectangles, you've got a hexagon here. And the exterior angle, so if you ignore the rectangles, if you just get rid of the rectangles and join them up the lines I've got, and my guess is that they're going to sum up to 360. They've got to sum up to 360, haven't they? It's not quite true, but basically every rectangle you're cutting off, basically that's 100, that plus that little bit there is 180. And the same here, that bit plus that bit's 180. So you're turning the right amount for just to add the exterior angles up. So we know that P plus Q plus R plus 55 plus 65 plus 60 is 360. But 60 plus 65 plus 55 is 180. So we need another 180 more. So we don't need to work out what P, Q and R are. I believe if it isn't that, I wouldn't know how to approach it. No worries. If you ever get anything American-wise, I'll happily do that. I think Vic's going to send me some of the ones he's done for his country. I can't remember which country Vic's from, but there we go. Right, we're now on to the last 10. Now, in normal challenges, these would be the tough ones. These would be the ones that you lose marks for guessing. But in this challenge, we lose marks for guessing any of them incorrectly. So here we go. For which value of k is the square root of 2016 plus the root of 56 equal to 14 to the power k? Well, the good thing is, have we not worked out what the square root of 216? We know that's the square root of 8 times 250. I've got it wrong. Let's go back. I've just remembered what I've gone wrong here. That is 252. 250. I was just weirdly, I thought I'd done nothing wrong in my head there. And 252 is 2 lots of 127. Oof. No, 126. Oh, I can't do it. And that is 2 lots of 63, and 63 is 9 sevens, and that's 3 threes. So 2016 is the same as 2, 1, 2, 3, 5 to the power 5 times, times 7 times 3 squared times 3 squared times 7. And so basically, if 2016 has one of these as a factor, it needs to have at least 3 2s. So basically the base number, 42 squared, needs to have at least 5 2s, which means the base needs to have at least 3 2s. So the denominator, the base, needs to be divisible by 8, and 3 and 7. So that's not divisible by 8, that's not divisible by 8. That is divisible by 8. Is it divisible by 3? It is. Is it divisible by 7? I think it's going to be C. Is it divisible by 7? It is. So it's going to be this one. Because 168 is going to be, just to double check, 168 is going to be 8, 20, 21. So it's going to be 2 cubed times 3 times 7. And if you square this, you double the powers, and then you've got enough to make this a factor. So it is C. Right, now, because there's no way that this question works if you can't find out the factors of 2016. So the good news is we've just done the factors of 2016. So this is the square root of 2 to the power 5 times 3 squared times 7. Plus the square root of 56 is the same as saying square root of 2 cubed times 7. And we need this to be equal to 14 to the power k. 14 to the power k. I'll deal with that in a sec. So this is the same as saying we can take a factor of 2 and 3 out of this first one. So we can say this is going to be, we can take a factor of 3 out. We can get 2 factors of 2 squared out. So 3 times 4 is 12. So we can say this is 12 lots of root 14 plus 2 lots of root 14 equals 14 to the power k. So this is 14 lots of root 14 is 14 to the power k. And if we want to write this in base 14, you've got 14 to the power 3 over 2 is 14 to the k. So it's going to be 3 over 2. Yeah, it's a good thing this question came up because I thought I'd got the last one wrong. And I might not have gone back to check it, but the fact is that this has to have some nice factors, otherwise this doesn't work. And I knew I've got the last one wrong. So Aaron had to choose a 3-digit code for his bike lock. The digits can be chosen from 1 to 9. To help him remember them, Aaron chooses 3 different digits in increasing order. For example, 2, 7, 8. How many such codes can be chosen? The last step you didn't know on this one here. Yeah, that's basically, this bit here is the same as saying 14 to the power 1 times 14 to the power half. And then if the bases are the same, you can just add the powers. So that's 14 to the power 3 over 2. Aaron has to choose a digit. Okay, digits chosen from 1 to 9. To help him remember them, Aaron chooses 3 different digits in increasing order. For example, 278. How many such codes can be chosen? My guess is it's 168, just based on the numbers. I think if the stipulation's in ascending order, it can't be these two. And clearly, I can already do more than 9, so it's going to be one of those two. I can clearly do more than 1 than 9. I can go 1, 2, 3, 1, 2, 3, 1, 2, 5, 1, 2, 6, 1, 2, 7, 1, 2, 8, 1, 2, 9. So I think it's 168. However, let's see if we can prove it. So, there's going to be an elegant way of doing this. I think I'm going to brute force this. My guess, I kind of just want to guess 168 now. So 1, 2, 3, 4, 5, 6, 7. Okay. First digit. Let's say the first digit is a 1. How many ways of doing the next two digits are there? You can have a 2 with 7 choices, a 3 with 6 choices, a 4 with 5 choices. 6, 7, 8, 9. So you've got a 2 with 7 choices, a 3 with 6 choices, a 4 with 5 choices, a 5 with 4 choices, a 6 with 3 choices, a 7 with 2 choices, or an 8 with 1. So if you pick a 1, that's how many different combinations of digits there are. If your second digit's a 2, you've got 7 choices to the last one. If your second digit's a 3, you've only got 6 choices for your last one, and so on. When you start with 2, you can have very similar points. You can have 6 plus 5 plus 4 plus 3 plus 2 plus 1. 3 is 5 plus 4 plus 3 plus 2 plus 1. And a 4 is 5 plus 4 plus 3 plus 2 plus, 4 plus 3 plus 2 plus 1. 3 plus 2 plus 1. 2 plus 1. 1. I think that's exhaustive. So if the first digit's a 1, you've got a lot more choice. If the first digit's a 7, there's only one option. And in total, you've got 1 7, 2 6s. There might be a quick way of doing this sort of maths. You've got 3 5s, 4 4s, 5 3s, 6 lots of 2, and then you've got 7 ways of doing it once. So it's going to be 7 plus 12 plus 15 plus 16 plus 15. It might be 84 actually. It might be 84 plus 12 plus 7. It's a good thing I didn't guess. 7, 9, 14, 20, 25, 27, 34. Okay, 3, 4, 5, 6, 7, 8, 8. Well, the good thing is I've got an answer that's there. If I didn't get an answer was there, there's something wrong with my method and I'm doing something wrong. But because I've got an answer that's at the top, pretty sure 84 is right, and it's a good thing I didn't guess straight away. I knew it wasn't the first two and I knew it wasn't the last one, just because their sizes are totally wrong. The circumferences of a circle with radius 1 is divided into 4 equal arcs. 2 of those arcs are turned over as shown. What is the area of the shaded region? Oh, well, if you cut this bit off, it will fill in this gap. And if you cut this bit off, it will fill in this gap. So you're going to be left with a square, and the square, it's going to be 2 I think. The square has a radius of 1. So to work out the length of one of the sides of the square, it's going to be 1, 1. We're going to have a right angle triangle, 1 by 1. A right angle triangle, 1 by 1. The length of one of the sides of the square is root 2. And the area of a square with a side length root 2 is 2. If you don't spot that, that becomes awkward to work out. But it's because you know that this arc is the same length as this arc, so you know those will fit in nicely. Let S be a set of 5 different positive integers, the largest of which is m. It is impossible to construct a quadrilateral with non-zero area, whose side lengths are all distinct elements of S. What is the smallest possible value of m? Let's read that again. Let S be a set of 5 different positive integers, the largest of which is m. It's impossible to construct a quadrilateral with non-zero area. Oh, okay, so so basically S is a set of 5 numbers. You can't make a quadrilateral with lengths from S. Yeah, it just can't be done. You can't be done. Okay. So I assume that the logic for a triangle doesn't work. So I'm going to extend the logic I know that works with triangles. If you have two lengths of a triangle like that, the third length has to be larger. Sorry, it has to be not larger than both of them put together. So if you think you have a triangle, to cap that triangle off, this length that you put on top here has to be smaller than those two put together. Otherwise, it can't fit the gap. It's too long for the gap. So if we imagine that the same works for a quadrilateral, so we have 3 sides, and the 4th side has to be small enough to line up with those 3 sides. So imagine we have a quadrilateral where you do something like that as our quadrilateral. That last side here can't be too big that it's bigger than those 3 put together, because then you can't make a quadrilateral. However, in S, that is the case. Yeah, so for a triangle, it has to be smaller than the lengths of the other 2 sides put together. For the larger side, has to be that. And in this particular case, I think with a quadrilateral, it works the same. So with a quadrilateral, we want 3 sides. So if we need M to be as small as possible. So if we had 1, 2, and 3 in S, 1, 2, and 3 is 6. That means we can't have 4 or 5 because they would work. So the next smallest number we can have is 6. And then if we try 2, 3, and 6, 2 add 3 add 6 is 11. So I think the next smallest one we can have is 11, because you can't put 11 with any 3 of these and make a quadrilateral. You can't put 6 with any 3 of these and make a quadrilateral. So I think the smallest possible number, as long as we pick 1, 2, and 3 as our first 3 digits, I think is 11. Michael was walking in Marrakesh when he saw a tiling formed by tessellating the square tile as shown. The tile has 4 lines of symmetry and length of each side is 8. The length of xy is 2, and the point z is such that xy is a straight. So basically z is xy is 2, xz and x and yz is parallel to the side square. Okay, so z is directly in front of z is directly beneath y. What is the area of the central great octagon? So we know this is 2, and the whole length there is 8. So if z is the point where they kind of where they kind of dip in, so we can say that you can cut that off, and because they've got a line of symmetry, do these two have to be the same size? So that middle square has got a 4. If x to y is 2, then this bit's 2 here, which means, because z and lines of symmetry and such, that the height of this bit is 3. The height of that bit there is 3, which means the height of one of these smaller triangles in the shaded area next to z, so the height of this triangle here is going to be 3/2. So to work out the area of the shaded section, I think we have 1 2x2 square plus 4 lots of those triangles there. So this is what I'm talking about, is that triangle there that I've shaded in light blue. 4 of those is going to be 4 lots of base times height, half of it. So 4 times 2 is 8, times 3/2 is 24/2 is 12, times a half is 6. And then, so the area of the square is 4, the area of the 4 triangles is 6, 4 plus 6 is 10. It is a number we've got. I think that's right. Yeah, let's go with that. The diagram shows 10 equal discs. I'm already going to hate this one because I've seen some of the answers. The diagram shows, I don't even remember doing this paper. I'm sure I was teaching when this paper was out. The diagram shows 10 equal discs that lie between 2 concentric circles, an inner circle and an outer circle. Each disc touches 2 neighbouring discs and both circles. The inner circle has radius 1. What is the radius of the outer circle? So what we're looking to get is the diameter of one of these. If we know the diameter of that one there, I'm going to have to do red because it's on shaded bit. So if we know the diameter of that one there, we can work out the diameter of the radius of the whole space. So we're trying to work out that length there. And don't think we're going to use pi, Steve. The fact is that 4 of my 5 answers have trigonometry. Where's 18 coming from? I know, 18 is half of 36, so maybe the clue's in the question. Maybe if we draw that triangle in there, the angle of that bit's 18, isn't it? So if we have one circle touching the larger circle, and we draw, that's the radius, that's the radius, that's 18. That's where 18 is coming from, because it's got 10 circles. One circle will take up 36 degrees of space because they're equally spaced. So half a circle, if you go from the centre of the larger one to the centre of one of the smaller ones, will take up 18 degrees of space. And then so my guess, weirdly, is it's one of these two. Are you playing Codenames later, Steve? Codenames in about 15 minutes. And that's 1. And that's a right angle. So there we go. There's a right angle. So we know we can work out R, I think, or at least we can work out R in terms of sine or cos 18. So hypotenuse and opposite. So it's going to be sine. So it's probably going to be this one. That's my guess. So if I was to have a guess now, I would guess C. So we can say that sine 18 equals 1 plus, R over 1 plus R. It's opposite over hypotenuse. So we can say that 1 plus R equals R over sine 18. 1 plus R minus R over sine 18 equals 0. R, lots of 1 minus 1 over sine 18 plus 1 equals 0. Go up here now. So R equals negative 1 over 1 minus 1 over sine 18. And the radius of the outer circle is going to be 1 plus 2 of these. So the radius of the outer circle, I've definitely run out of space here. Can I delete the diagram if I rub out the diagram? So let's, the eraser on this is rubbish because I can't, such a tiny bit of space. So hopefully that diagram made sense and it's working. My guess is it's C and I just need to rearrange it. But it feels like I've got all the bits I need to for C to work. So the radius of the outer circle, so outer rad, is 1 plus 2R. Well, R is this. So we've got 1 plus 2 lots of minus 1 over 1 minus 1 over sine 18. It's got to be C, it can't be any of the other ones, but I have to sit here and rearrange this. So that's the same as saying 1 minus 2 over 1 minus 1 over sine 18. And if I was to simplify the denominator here, that could be because you can get a sine 18 on the numerator here. You can write 1 as 1 minus 1 over sine 18 twice, and you get sine 18 on the numerator. It's going to be C, and I'm not in the position where I want to try and rearrange it. I've got an answer. I'm pretty sure it's C. What am I doing wrong? I need to change this denominator, so I need to change that to... I'm going to come back and do that. Should I do it now? Do you want me to do it now? It's C. Pretty sure. Well, as soon as I knew it was going to be 18 degrees and sine, I could probably eliminate all the other answers. Oh, I'm going to have to do this to satisfy the people. So this is the same as saying 1 minus 2 over sine 18 minus 1 over sine 18, which is the same as saying 1 minus 2 sine 18 over sine 18 minus 1, which is, I'm getting very close now, aren't I? Which is the same as saying that's going to be sine 18 over sine 18 minus 1. I've dropped a negative somewhere. But it's going to be C. It's going to be C. I've done something wrong, but it's going to be C, so I'm going to guess C. Alright, I usually like these, but I don't think I've ever seen them come up this late in a paper before, so we'll see how difficult it is. 3 friends make the following statements. Ben says exactly one of Dan and Cam is telling the truth. Dan says exactly one of Ben and Cam is telling the truth. And Cam says neither Ben nor Dan is telling the truth. Which of the 3 friends is lying? Oh my god, it could be all of them. Right, the way to approach these, and this is where this is sometimes hard to explain, the way to approach these is to assume they're telling the truth. And if you ever get a paradox, they can't be. So let's say that Ben is telling the truth, which it won't be, because it won't be. It's nearly always the first person telling false in these, because they want you to go through all the different options before you get an answer. So let's assume Ben is telling the truth. Exactly one of Dan and Cam is telling the truth. So now we need to break this into 2 bits. We know if Ben's telling the truth, then one other boy is telling the truth. So if Ben is telling the truth, and according to Ben, let's say Dan is telling the truth, that means Ben and Dan are both saying each one of the other 2 boys is telling the truth. They're referring to each other, which means Dan is lying. So I think that works, doesn't it? If Ben is telling the truth, and from his point of view, Dan is telling the truth, then each of them are referring. So Ben says Dan is telling the truth, and Dan says Ben is telling the truth. They're both implying that Cam is lying. So if Cam is lying, is this statement a lie? Neither Ben nor Dan is telling the truth. That's a lie, because they both are. So I think it's just Cam. Usually I don't do them that quickly. I think that's right. I'm going to go with it. Let's go with it. A cuboid has sides of length 22, 2 and 10. It's contained within the sphere of the smallest possible radius. What is the side length of the largest cube that will fit inside the same sphere? So if you have a cuboid and you're trying to fit this in a sphere, basically to fit this in the smallest possible sphere, the largest part of the cuboid will be the sphere's diameter. And the largest part of a cuboid is the diagonal from one corner to the other. And to work out that length, if we work out that length, we'll have the diameter of the sphere. But I think it's probably better to work out the radius of the sphere, so we're going to work out half of this length, I think. So half of this length will be the square root, it's just 3D Pythagoras, of 11 squared plus 1 squared plus 5 squared, which is going to be the square root of 121 plus 1 plus 25, which is the square root of 147. So we think the radius of the large sphere is root 147. Now, the radius of the large sphere, once you put in a cube in it, it's exactly the same thing. The diameter of the longest part of the cube will also be root 147, or at least from the radius, because the center of the cube will be the same as the center of the sphere. So basically that distance there is root 147. So if we go backwards and we say that root 147 is half of the length of, let's call the length x, we can say this is the same as saying half x squared plus a half x squared plus a half x squared is root 147, I believe. This is going to be maybe we say that's 2x, just to make the maths easier. Alright, so we get 3x squared is 147, x squared is 49, so x is 7 and 2x is 14. There we go, that works. That was nice. For question 23, that was not bad. The diagram shows a square PQRS. The arc QS is a quarter circle and the point U is the midpoint of QR. So U is in the middle. And the point T lies on SR, but not in the middle. The line TU is a tangent to the circle. What is the ratio of the length of TR to the length of UR? So we're trying to find out this length compared to that length. Well, that length there, let's just say, do we have the length of the square? We don't. So let's just say the square's got a length of 1. No, 2. We'll do 2. So that's 2, and that little bit there's 1. And then we have to work out this length there, x. So t is beyond the midpoint, so RT is larger than 1, so x is larger, looking at the diagram. I'm pretty sure that's true anyway. Got a tangent. Is there any point in working out the length of p to that length there? I feel like we need to work out the length of ut, because then we can do Pythagoras. Can we work out the length of ut at all? Can we work out the length of st? Well, I suppose you can work out st, you can work out x. So you probably can't work out st. Any clues, anyone? Alright, I'm going to come back to that. Let n be the smallest integer of which 7n has 2016 digits. Lovely. What is the units digit of n? Alright, so 7n. I'm just going to do this and I'm going to come back to civilian. Oh, okay. Yeah, take a picture if you want. Oh, actually, I think QU is 1, But because QU is also a tangent to the circle, isn't this line also one because tangents are equal in length? Does that help us? We can say U to this point here, the point where the tangent meets the circle, that point there, we can say U to that point there is 1 because QU is 1 and they're both tangents that meet at U. Which means that this is 1 minus x, 2 minus x, and as is the same as this, that's 2 minus x as well by the same logic, because ST and the TT and the point where the tangent meets the circle are also two tangents. So I think you've got a triangle here where you've got 1x and then 1 plus 2 minus x, or 3 minus x. And so we can work out, we know that 1 squared plus x squared is 3 minus x squared. 1 plus x squared is 9 minus 6x plus x squared. You get the x squareds will cancel, that's lovely. So you get 1 equals 9 minus 6x. You get 6x equals 8. You get x is 4/3. And because you're comparing x to 1, it's going to be 4/3 to 1, so the ratio is going to be 4 to 3. Look at the two kites formed by the radius. Oh yeah, that's basically what I've done, isn't it? Because we know that P to this point is 2, because it's the radius of the circle, yeah. And that's a kite. Yeah. But I've got it. We know that 7n, where was that? 7n's the number with 2016 digits. N is the number we have to find out. So 7n has to be, if it's the smallest number, so it's got to be 1 0 0 0 0 0 0 0 0 0 0 0 something. And we need the number that goes there to make this number divisible by 7. So if I think when you start to divide by 7, you get repeating bits. If we divide this by 7, we can work out n is this divided by 7. So if we try and divide it by 7, what do we get? 1 0 0 0 0 0. We're going to get some repeats, aren't we? So let's see how often it repeats. Is it, well, not 1, but question mark. In theory, x. So we'll divide it by 7. So 7's into 1 doesn't go. 7's into 10 goes once, carry 3. 7's into 30 goes 4 times, carry 2. 7's into 20 goes twice, carry 6. 7's into 60 goes 8 times, carry 4. 7's into 40 goes 5 times, carry 5. 7's into 50 goes 7 times, carry 1. 7's into 10 goes. Okay, so we've got our repeat. We've got our repeat, and they repeat 6 digits at a time. So 7's into 10 goes once, carry 3, and so on. So there's 2016 digits here, and it repeats every 6, but not including the first one, because this is you're going to lose this 0. So the answer is repeating every 6. And then what we need to do is fix the last digit so that it isn't a 0, so it doesn't repeat, but we need to know when it stops repeating. So you're absolutely right, n does have 2, so this number at the top is our n, this number at the top is our n. So we know that n has 2015 digits and they repeat every 6 times. So how many 6s in 2015? It is, so how many 6s into 2015? None, carry 2, 3, carry 2, 3, carry 3, 6 5s carry 5, remainder 5. So we need there are going to be 5 digits left at the end that we need to deal with, of which you're going to have you're going to have a 1, 4, 2, 8, and then something that doesn't repeat. So 8 would carry over 4, so normally we'd have a 4, which means we'll need that to be a 2 rather than a 0, because if it was a 0 you'd get a repeat. So we'd need the last digit of 7n to end in a 2, which means the last digit of n would end in a how many 7s in 42? It's 6. We think it's 6. Thanks, Ignatius, that helped. I think that's right. Alright, well, let's mark it then. You just have to round the 5 up. Yeah. What, this 5 here? Yeah, it can't be the 5. Okay, so we're going to go back to the start and we're going to mark it with our green pen. So if you've done this yourself, we're going to mark. There's definitely a couple I had to go back to. I mean, this is the senior one, so this is the hardest one, but generally I don't get full marks. I imagine I've gone somewhere wrong, but thanks to my chat, they pointed some stuff out to me. Have I got the answers up? No, I have not yet. So, alright, I've got the answers up. So we're going to mark it. Remember, the way it works is you get no marks if you left it blank. You gain 4 marks if you get it right, and you lose a mark if you get it wrong. Those last 2 are difficult. I actually thought some of the other ones were difficult. The penultimate one's the hardest one, I think. Maybe. AJ got it. Right, question 1 is B. Question 2 is D. Actually, have I finished ahead of time? I finished ahead of time. I actually think this is one of the easiest senior ones I've done. However, I think I might have seen it before because I was teaching when this came out. 3 was B, 4 was C, 5 was A, 6 was D, 7 was A, 8 was B. I thought that was hard. There's probably an easy way of doing it. Oh, they're just triangle numbers, are they? No? Not sure. That's what it says in the answers. 9 was C. 10 was B. 11 was E. 12 was C. 13 was A. 14 was D. 15 was B. 16, swap pages, 16 was D. I like that one, that was really nice. Triangle numbers times 4. Oh, right, okay. Is that what they were, was it? Hey Sol, I'm not sure I said hi to you today. So 16 was D, which I changed to green pen obviously because we're marking it. 17 was also D. 18 was E. That was easy. 19 was D. 20 is E. I didn't like that one. 21, I actually think this is the hardest one. 21 is C. Now, what have I done wrong? I'm going to come back to that because I definitely got something wrong because I wasn't quite getting the right answer at the end of it, but I knew it had to be that answer because of all the sign 18s I had. 22 is C. That felt easier than it should have been. 23 was E. 24 was B, and 25, we just double check, was D. I don't think I've ever got full marks on these before, so thank you for your help, guys. So we score. We got 25 marks that they gave us at the start, and we got 25 lots of 4, for a total of 125 out of 125. If you've done this yourself, post a comment in the score below. Please let me know if you like my videos and if you want to see more. But I'll be back on Twitch if you want to watch me do these live. If you follow me on Twitch, the link at the bottom. And I look forward to speaking to you soon. Please let me know how you're finding them and when your next challenge is yourself. But as always, peace out, maths for now.